Hello, RGL3300 students. Back for lesson 12, which will be our last lesson because we'll be having our exams next week. This afternoon's Zoom call regularly scheduled for 4 o'clock. We'll discuss, very briefly, we'll discuss the final exam because your papers for this course have already been submitted. This lecture will also be relatively short, not because the topic isn't important, but because we've discussed throughout the course in various ways some of my pet peeves about post-market surveillance and pesticides and industrial chemicals. So I'm not going to spend a lot of time on this topic. We've went through it. You have the slides. And so let's just quickly go through and remind ourselves of some of the key issues for post-market surveillance in these areas. All right. As I've said previously, unlike pharmaceuticals, the market for pesticides and industrial chemicals is much more diffuse and dispersed. Pesticides are less so than industrial chemicals, but compared to pharmaceuticals, they're much more dispersed, and they have much more multiple uses than your typical pharmaceutical process. Pesticides manufacturing produces for a wide range of sectors, both households, agricultural, industrial sectors, okay? And for example, and there's a lot of them that come onto the market very steadily. In 2016, 2017 alone, for example, 10 new active ingredients were approved, which resulted in 24 new related end-use products. So there are a lot of them out there. And their uses are scattered across, like I say, the professional agricultural community, household use, industrial use, like keeping plants away from rail lines, for use with housing products to keep bugs away, these kinds of things. There's all kinds of uses for pesticides that can go on and on and on about it, okay? Highly diverse, and for industrial chemicals, as I say, even more so the case, right? So both of these areas, present quite significant challenges, all right, for post-market surveillance. The National Pesticide Compliance Program is primarily where most of the activity occurs. Unfortunately, it's not really geared towards post-market surveillance. It's geared towards compliance promotion. And that's quite a different issue than post-market surveillance, where in post-market surveillance you're trying to interpret whether the residual risk of approved products or approved regulations are within parameters or outside parameters. The pesticide post-market surveillance doesn't do a particularly great job at that because that's not specifically how it's designed. Regulatory compliance, as I say, is the primary emphasis of that program. For example, in the Pest Management Regulatory Agency Annual Report 2016-2017, the PMR detected non-compliance, including possession of an unregistered product, import or use of unregistered products, use contrary to the label approved by the PMRA. Surveillance inspections, the term used by PMR, are actually compliance promotion activities as we have defined them, okay? And this is something quite a bit different from the post-market surveillance as we've just defined it. And of course, this is one of my pet peeves in the whole area of pesticides, as we have discussed multiple times through the program, okay? One obvious strength that sort of goes against the criticism that I've been leveling is that the data from poison centers, right? That's one area where we can get some significant post-market surveillance. But in terms of mixtures in the environment, impacts on soil, impacts on pest resistance, all of the other factors that would go into a quality post-market surveillance system are not monitored on a consistent basis. I mean, let's be honest about that, and I think that continues to be a significant problem for pesticide management throughout OECD countries, actually. And the reason for that, of course, being the difficulty of monitoring these things in post-market surveillance, but also in the strong economic arguments that are made for why pesticides are needed. And before you can eliminate a pesticide that may be a problem, and I've been sending you stuff on that, I think you know what I'm referring to, you need to be able to identify alternatives. These are strong arguments that tend to push back against public goods in the area of ensuring that pesticides are safe and are used in the proper manner. Okay? And significant data gaps even in poison centers exist, okay? I mean, poison centers will report a poisoning related to a pesticide if that causation is perfectly clear. If that causation is not clear, a lot of these things will be, the patient will be treated and moved on their way. And the reports may not be comprehensive back to any post-market surveillance system. And I think that's the reality. We've discussed this many times. I've talked to you about the passive system. And the fact that, you know, that passivity basically relies on the company that's producing the pesticides to report any anomalies. Well, we've seen in the politics with Monsanto, Bayer, and others that what is the likelihood that this is going to be the case, all right? So that's an area, there's no question, that's an area of weakness in post-market surveillance across the various classes of our the three classes of chemicals that we've addressed in this program. Now that said, in the same areas that for the same reasons that we have to deal with industrial chemicals, we can deal with pesticides through biomonitoring and environmental monitoring, and that is done in a more systematic basis. And we'll discuss that in a moment, okay? In industrial chemicals, of course, the diversity is even greater, and we've discussed this many times. We have industrial chemicals in our own households, from the least hazardous to the most toxic and most hazardous, most caustic and most hazardous that you can find. Industrial chemicals span such a huge range and such a huge range of uses. And of course, pharmaceuticals themselves are industrial chemicals, but we're not talking about that in this case, okay? And again, we can capture some of the impacts of industrial chemicals through poison centers. We've discussed this through worker accident reports and these kinds of things. And those work reasonably well when it comes to industrial chemicals, those direct human health effects. But the ecosystem effects have to be monitored in a different way. We don't have the professional networks of reporting from, like we do with pharmaceuticals, from doctors, nurses, pharmacists, these kinds of things. We have in industrial chemicals, we have so many uses, so many chemicals across a broad diversity of people and organizations using them, that trying to get that kind of a reporting mechanism in place for industrial chemicals would be virtually impossible. Okay, so as such, governments, you know, must judge the effectiveness of laws and regulations through independent monitoring of harmful chemicals in Canadians and their environment. That's biomonitoring and environmental monitoring, okay? That's typically done in cooperation between Environment Canada and Health Canada, as you well know, under the provisions of CEPA, okay? Which CEPA, as you also know, is a government-wide piece of legislation. That's the Canadian Environmental Protection Act. And the authority for that act is shared between Environment Canada and Health Canada. A key element of Canada's Chemicals Management Plan is the monitoring and surveillance of levels of harmful chemicals in Canadians and their environment. Monitoring involves the regular collection of physical, chemical, and biological data. All environmental media are assessed, including air, water, sediment, non-human biota, fish, and wildlife. Source monitoring is also completed: wastewater treatment plant, effluents and sludge, landfill, leachate, biogas, etc. Environment monitoring is combined with human health monitoring conducted by Health Canada. For example, when we do a quality of environment report, we would be talking about both ecosystem monitoring. We're finding these chemicals in the environment at a level that they shouldn't be at, or biomonitoring, where we're taking blood samples from say Indigenous people in the north to determine whether they're still getting unacceptable levels of exposure from mercury in fish or seals or whatever the case may be. And that's basically the only way we can maintain post-market surveillance for this wide span of chemicals. and the wide span of their use. Okay. There are three broad categories for conceptualizing different uses of monitoring. One is systematic monitoring, or impact monitoring, which is typically deployed to assess over time, especially problematic areas such as stressed river systems or urban air quality, to determine trends and needed corrective actions in policies and regulations. Random monitoring, or what we call compliance monitoring, is used to verify the compliance reports of enterprises and more broadly to assess the effectiveness of compliance promotion activities. That's when the government will send an inspector out according to a monitoring plan, without notification, to take samples from the end of a water pipe, an emissions pipe from a plant, or the air stack from a plant, or whatever the case may be, to determine whether the compliance is actually present. And also to confirm the reports sent by the company to the government with respect to its environmental performance. So the government gets a report and it says, you know what, this percentage of companies are going to be up for random monitoring to determine whether what they're reporting is actually truthful, or if there's any errors in the data, we want to know about it. All right. And then there's self-monitoring of environmental performance, which is required in Canada for businesses over a certain size. And the reason for that, of course, is businesses cannot know if they're in compliance with standards unless systematic self-monitoring occurs. If a business reports that it's in compliance, it better have some data to demonstrate that it is in compliance. And it's in the case of random monitoring, the government inspector would go out to determine, well, is that data accurate? Is the report accurate? But obviously, because monitoring is very expensive of this kind, it's rarely is it conducted without a government developing its annual monitoring plan, which would be kept secret, right? And it would be much the way a police force would establish a patrol priority pattern for the limited amount of police cars that they have. The same thing applies to environmental monitoring plans. It would be set up a system for increasing the probability that we're catching everything. We would do it. We would say that we would obviously target the most high emitting companies with the highest risk of quite damaging pollution. Another criteria would be applied to say, okay, if we're going to do 400 random visits this year across the country from all of our regional offices, what should they be? And we're not going to tell anybody. We're just going to do them. All right. But we're going to do them based on prioritization because of obviously scarcity and opportunity cost. All right. So, and one of the key things to keep in mind with monitoring too is that because it's one of the only ways that we can monitor, like we can literally post-market surveil the impacts of a lot of pesticides and industrial chemicals on human health and the environment. And they tend to be expensive, but they also tend to be the targets of politicians who maybe are catering to business interests and they don't want this information to be known. They would prefer that post-market surveillance be more lax. It's one of the first areas that politicians of that stripe will attack when they get elected. It's what Donald Trump did, right? What's one of the first things Donald Trump did when he got elected? He basically gutted the US EPA's monitoring capacity and other science capacities. This is a common tactic because then what you have is you have approval of these pesticides that meet certain thresholds, and we already determined that these thresholds can't be, acceptability of them can't be determined scientifically. The science can tell you where you are on them, but acceptance of those thresholds is political. All right, and so politicians come in and they decide that one way of cutting down pressure on more strict regulation with respect to these chemicals is to not tell anybody what's happening in the post-market surveillance side. And it would be naive to believe that that's not a large part of the story in relatively weaker post-market surveillance when it comes to pesticides and some industrial chemicals. All right. Now there are many examples of where for monitoring had done a really good job, right, in telling us that we were in trouble, and we have a long history of that in Canada. Lake Erie, St. Clair River, in Mercury down river from from pulp and paper mills. We've had lots of examples. We discovered persistent organic pollutants in our north where they were never used through monitoring. So there are lots of really, really good success stories as well. But what I'm saying is that unless monitoring is kept up and investment in that is kept, we don't really have strong ways of knowing what's happening to human health and the environment in the area of pesticides and industrial chemicals without that systematic monitoring. And that's why it's there, all right? Because we don't have the tight network of post-market surveillance and pharmacovigilance, all right? Now, there are claims that we do post-market surveillance in other ways and reporting and from companies and all that, but we know the reality, okay? The reality is going to be quite a bit different than that, and without post-market surveillance monitoring of the type we're talking about, our data sources will be very poor. And as it is, in an ideal world, we would be doing a lot more monitoring, but it's very expensive. It's expensive to monitor, okay? You have to maintain a team, you have to send people into the field, you have to have the lab capacity. And some lab capacity is very expensive. If you're assessing, for example, dioxins, furans, and coplanar PCBs out there, that requires a wet lab. A wet lab is very, very expensive to build and assemble and maintain the equipment. So these are constant. This is a lot of the politics around post-market surveillance and in that broader classes of chemicals, pesticides and industrial chemicals. Okay? So I'm looking forward to talking to you on this afternoon's Zoom call. The emphasis of that Zoom call, of course, will be the final exam because your papers are already in. I'm looking forward to seeing seeing that people are attending the Zoom call. I wouldn't miss it because I'm going to tell you about when the exam occurs, when it's due, and I will read out the core question. All right? So on that score, talk to you this afternoon. Okay, bye-bye now.